So just to set the groundwork here, this is a project that I worked on for my grad school program, so that's why you might notice I've got 3 names at the bottom, and they're all remote because I'm doing an online program, but I think it would be unfair to get up here and pretend like I did all this work on my own. It was definitely a group effort. And I'll also say that the intent of this presentation is really just to get your mind thinking about how to use natural language processing as a potential solution to analyze data. Unfortunately, we just don't have the time for a tutorial to walk you through the entire process step by step, but hopefully get you thinking. The tools we were supposed to use for the class. It was RapidMiner, and we used some jump. But you could do these methods with R, Python, I'm sure Java. So don't let the tools limit your imagination in this issue. Okay. So we use the traditional CRISP-DM process where you start by determining the purpose of your study, you explore the availability and nature of the data, you prepare the data, you develop and assess the models, evaluate the findings, and deploy the results. And we chose this topic because, as you can see from this chart from our World in Data, global reported natural disasters are on the rise, all across different types. So the good news is that fatalities is going down. If anyone is familiar with Hans Rosling, it's not all a bad doomsday story, but with climate change, we're definitely seeing more activity. And I will also let you know, there's a lot of stuff on these slides that most of you probably will not be able to read because of the size of this room, so don't fret. I will discuss kind of the key points. And here we just list out, we had questions that we wanted to answer, and then we had our methodology. So the main questions that we wanted to learn from disaster analysis were, 1, how do various disaster events compare to each other based on the tweets? What can be learned about the needs of those experiencing the disaster? And what words are most associated with various types of disasters? And can we predict the amount or type of damage from certain disasters? And you'll notice these are very lofty goals, and we didn't achieve everything we set out to do, but that's common when you start on a data problem or any research problem, that you often won't be able to achieve what you set out to do, but you will find things along the way that you wouldn't have found otherwise. Okay, so one of our other limitations is that we were using student software, and if anyone's familiar with student software, there's often a line limit to make sure that you're not taking that software to your employer and just running millions of records through it. So if you were using like an R, Python solution, you could probably get around this limitation and have even more robust research. So we knew that because we were using RapidMiner, which is this little guy here, that we could only process so many tweets per day in our sentiment analysis. It was a low number of like 10,000 tweets. And we were able to find data online that showed tweets from all kinds of disasters all across the world. And you'll notice here the total size. We had quite a bit from Hurricane Harvey, not as many from Sandy and Joplin tornado. And if we didn't even these out, we would have gotten skewed results. We couldn't just put all of that in there because you wanted to kind of level it out. So we did a sampling of 4,000 tweets from all 4 disasters. So kind of crude, but gets around that problem where we had way more data from Hurricane Harvey. And then the campfire, so this project was done a year ago, and we actually did it during the campfire situation. So I was pulling campfire tweets myself through RapidMiner. It wasn't pulled from the source website where we got the other tweets from. And so it was kind of interesting in real time. We got to choose our topic and then being able to be so close to such a horrendous fire happening and build that into the research. And so all of our data sets were in English, and we can see the years that they occurred. A few limitations, so again, our data set was very small, and we didn't have data on flood, earthquake, or many types of disasters, And we also didn't have very many instances. You know, Joplin tornado was the only instance to represent a tornado event. Ideally, you could get many tornado disasters in there, etc. And then these are the software that we used. You can see there's the Jump Pro. We did a little bit of Tableau analysis. And then, so getting our Campfire tweets. So we had about 1,289 in total using the RapidMiner extension, but we did exclude retweets and any link addresses. That kind of limited your results because often people will tweet during a disaster sharing an article that they found, but we were excluding anything that was article-based. So it had to have been kind of an organic tweet of somebody saying, you know, my neighbor's house just blew away, like with no other, you know, link in there or retweet, which also limited our data set. And so then we got to tokenizing, and I won't go too far into the details of tokenizing your data, but you are trying to basically make each word its own entity, because if you're familiar with data sets, if you have like a comment field from customers, you have one field that's going to contain all the text, and that's going to be a unique record. So really the best way to analyze data is you need to break out each word in all of the textual data you have in order to start analyzing without it recognizing each of those records as being a whole entity. So we excluded words that didn't appear over 20 times out of the 4,000 tweet sample, and we removed stop words. So stop words are typically in, out, and, but. So, you know, typical words that you're going to see so often, you don't want them muddying up your data. And we also removed tornado, fire, storm, because we expect those to be in the data. And so ultimately, once we had our stop words, you'll notice the little dot on the end, and that is because, for example, the word pray. You could have praying, prayer, prayers, and you want to capture all of those in the same thing, like with warn, warned, warning. You don't want to overcount or double count just because of different iterations of the same word. And we came out with about 5 different clusters, and the clusters have to do, the software basically tells us what words are related to each other and often used together, and then you can kind of see the main themes. So looking at these stemmed words, I just created this word bubble, you know, gotta wow the professor somehow. You can see there's like now, watch, people, help, victim, need, damage, prayer, day. You know, I wouldn't say this US-shaped word bubble is your ideal choice because it's kind of hard to see all of them ranked together, but it looks fancier than just a simple circle. And then here you can see the clusters. So what we found with our cluster analysis, again, the themes, grouping these words together, is that basically the tweets that contained these words kind of fell into these broad groupings. So the words in cluster 1 were generally from government and information, alerts, and warnings. Cluster 2 was what's needed and people grateful for help received. Cluster 3, down here, is the audience, or those watching and sharing what they see. You have the well-wishers in cluster 4 that are praying, hope everyone's safe. And then cluster 5, you have evacuations and human safety. And you can tell just from the bar chart in the corner that by and large, most of the tweets we came across were from cluster 1, government warnings and issues. And that actually makes a lot of sense because the problem with Twitter is I don't think a lot of people are getting on Twitter asking for help. You know, you might get on Facebook if you're local to say, hey, anyone in the neighborhood have a truck we can borrow to help us evacuate or whatever, but you're probably not going to tweet to the Twitterverse, like, anyone have, you know, want to help me board up my windows, you know. Probably shouldn't tweet that, you don't know who would show up at your house. So I think the ideal situation with this type of analysis is if you could get into like the Facebooks and get that personalized messaging. But the only thing we really had access to was Twitter with our tool, and we were supposed to use Twitter for our project. And obviously a lot of Facebook is publicly or privately made posts. So here we looked at the polarity and the sentiment, And the red, or pinkish, I guess, represents negative, the blue is positive, and that kind of gray color is neutral. And so what you will notice is that Camp Fire, compared to Hurricane Harvey, Sandy, and Joplin, is much more polarized, but that makes sense because the Camp Fire didn't have really any warning, and generally wildfires don't. A hurricane, we're watching it for 2 weeks, moving off the coast of Jamaica, like swooping up, and so we get lots of warning. We know the size, we know the damage, and a wildfire doesn't give us that same warning. So therefore, a lot of the tweets around Camp Fire were after it already began, and they're reactionary, and it's shock and disbelief versus, the warnings that we get with other storms. So this shows confidence level, and so one thing I know this is hard to read, but the dark blue represents high confidence in our polarity. And so Hurricane Harvey and the Camp Fire had the highest confidence, where our model was sure that it was getting the sentiment correct. And it's important to understand your own confidence in any model that you're doing, because the model might tell you one thing, but you have to pay attention to whether there's a high degree of confidence in what the model is trying to tell you. And then we did some naive Bayes and neural net, and this is kind of where we try to predict a disaster type. And you will see, well, you probably can't see, that Hurricane Harvey had Joplin tornado had the highest prediction for neural net down here at 99.66%. And then we had, Hurricane Harvey at 97. And then Hurricane Harvey was highest in naive Bayes at 97.28. But I think one thing to remember, especially for the tornado case, is that we only had one tornado event. So if there's something distinct about that within our 4 disasters, it would be pretty easy to maybe identify Joplin. It would be a better test if we had like 15 tornado events to see if it could predict which event this was from. So this didn't work maybe as well because of our limited data set. But we had to do it for our assignment. And it was a good exercise just to see how these different models performed. Going into our bootstrap forest, a little bit easier to read. You have the training, validation, and test set. And once again, you'll see that, well, actually this time with bootstrap forest, the Sandy turned out with the highest precision. And precision just means when we picked out what we thought mattered, did it prove to matter, or did we grab the wrong things with our model? And then the prediction level at the bottom, the recall, just shows how well that we were able to reproduce once we went into our testing. And so overall, not super great, but again, we only had about 1,000 tweets from each event. Very small data if you think of the world of this type of work. So what contributed to, over here you'll see that these are the words that contributed to our bootstrap forest model. And so warn was one of the biggest predicting terms. Status, thank, watch, help, and burn. And so this supports our earlier observation that much of the tweet activity during disaster events is centered around government communication. And then here, this is our plot of partial contributions to inertia for the column points. And so since our TDM reduces all input variables to a set of binary values, we had to perform this multi-component analysis to identify the dimensions and key columns. So if you see the top is the dimensions, which are coming off of, similar to those clusters of help, thank, burn, contain, or status, warn, path, strength, warn, collapse, watch, photo. You can see Camp Fire was mainly made up of dimension 1, and then the Hurricane Harvey, dimension 2, and then Hurricane Sandy and Joplin tornado at the end had a large amount of dimension 3. And sorry if this is a little weedy, but some people try to hit everyone, give everyone the basics and the person hungry for more. Okay, what we ultimately learned from all this analysis was that information in these types of events is really the greatest need. And that sounds like common sense once you think about it, but at the time, you're like, should we send clothing? Should we send water? Should we send, we need all these things to survive. But ultimately, especially in the case of Camp Fire, information made a lot of difference. So most tweets are government-issued warnings and neutral. People don't turn to Twitter for help. Wildfires come with little warning, and thus they're very polarized. Words like please emphasize the urgency, and tornado hurricane words associated were strength, watch, path, warn, status. And unfortunately, there's really no measurement for wildfire strength. We simply refer to the size and containment, and then the impacts and civilian response, less heating. So we ultimately weren't able to use our data to predict disaster like we wanted to do. You would need much more data to do that. But it does raise an interesting question, which some of you have probably already thought about. But there was a really thought-provoking, and I thought it should have won like a journalistic Pulitzer article on the Camp Fire. And apparently it was estimated that only 30% of Butte County residents received an alert to evacuate, because after the last wildfire event, they went to this opt-in system where you had to opt into these alerts, and people didn't know that they were supposed to opt in. So only about 30% of them knew that they needed to evacuate, and sure, there's some word of mouth eventually. And then the roads were not built for the capacity of evacuation needed, and it resulted in 88 people dying, and harrowing stories of bottlenecks as people fled for their lives while their shoes melted to the pavement, which is discussed in this article. And it kind of makes you wonder, obviously I don't work for the Weather Channel or anything related to weather, but what sort of system we could start to develop as far as measuring wildfire events, like with how quickly they catch fire, how quickly they grow. Like we talk about containment, we could talk about size, but maybe some algorithm that would say if you're so far from main roads, or if you're in a certain county level of population density and it's growing so quickly that maybe we can start measuring the scale and the strength, because that impacts how we talk about these storms, natural events, and ultimately, how we do evacuations, because that's just unacceptable if you think about a community that lives in a high wildfire area to only have 30% of people alerted to evacuate. And just to put it into some scale, because Hurricane Sandy had 233 fatalities, but Hurricane Sandy, looped up from, Bermuda and down by the Bahamas and came up and impacted the mid-Atlantic. But the Camp Fire was a relatively small area. The bottom left graph or map, you can see where it actually took place, and then the right side is an overlay over San Francisco and the Bay Area. So it's an awfully small area if you think of resulting in 85, I need to update the previous slide, 85 fatalities compared to 233 with a storm that actually had a much larger area of damage. So if you're interested in learning more about natural disaster data, hard to see, but ourworldindata.org, natural disasters, they actually have a lot of data on terrorism, all kinds of things like, hunger, starvation. And then this is that New York Times article, California fire, what started as a tiny brush fire became the state's deadliest wildfire. And that's the one that I honestly think should have won a Pulitzer, talking about kind of what went wrong. And then we did ultimately have to submit like a white paper on this, and so if you'd rather read that than my overview here for more detail, just let me know. I'll be happy to share it with you. It was not published anywhere. It's not, not that important, but if you just want something a little more detailed, or you can email me, tweet at me, or message me, and I'd be happy to discuss more on this topic. I saw a really cool example last night, actually. Somebody scraped 38,000 headlines about millennials to try to figure out everything we had killed. The doorbell industry, American cheese slices, the American car, like all these things. But they had other words in there too, like you could search strength, and it was kind of like all the words that are associated with millennial strengths. So there's a lot of fun things happening around natural language processing, especially the ability to scrape the web. Really, your options are endless. I know somebody who was using this in R and for disasters and wondering how you could do that with shooting events. And I don't think we'd have to wonder the polarity of a shooting event, but might be some interesting insights, and just a lot of stuff is coming out of this. And so I hope you guys found some value. We're kind of pressed up on time, but if you have questions for me, again, email or you can catch me sometime today. So, thank you. Okay, we have time for questions.
Yeah, a couple of questions if you want, if you have any.
Can you go back to that website page, please? Ourworld.org, is that what
Yeah, Our World in Data. So there's some really interesting statistics, and it's unbiased. You know, it's an organization. I don't know the weeds of who's behind it, but I actually went to their website to look up terrorism data because right now in the U.S. with the opioid crisis, I mean, Americans are more likely to die of opioid overdose or addiction than, you know, somebody in the Middle East is to die of a suicide bombing or a terrorist event. And so not only are we way too concerned about terrorism in the U.S. happening here, but the fact that our opioid crisis is worse than the terrorism threat in the Middle East. So it's interesting to put things in perspective and go to that website of what's happening. And they have a lot of other charts on disaster events. I could have filled like the first 15 slides with their charts, but you guys didn't come here to look at their charts. Any other questions? I know that as far as like presentation etiquette, I did a horrible job of making sure you guys could read everything and the rule of like not putting too much on there. So I'll know for next time. So sorry about that if it was a little overwhelming, you know. I was trying to stun you so that way you would just submit to my presentation. Hopefully it worked. Okay.